Assalamualaikum. My name is Ahmad Danial bin Zafrul from Group I. Our topic will be significance of tribology properties of surfaces in machining technology. For machining is a removal process in which sharp cutting tool is used to mechanically cut away material. There are two types of machining, traditional machining and non-traditional machining. Traditional machining is a process remove material from the workpiece surface by using tools that are harder than the workpiece material. And for non-traditional machining, it can be categorized on the basis number of action required to remove material from the workpiece specimen. For traditional machining, there are two types or two examples. Machining by abrasion, we can see the depth of penetration is not uniform for all the abrasive particles. And machining by cutting, the tool is penetrated in the workpiece material to require depth of cut. For non-traditional machining, there are single action non-traditional machining, which are three examples. Thermal machining, a single machining action is required to remove material from the workpiece. Mechanical machining, mechanical abrasion is the main mechanism for the material remove. And the chemical and electrochemical machining, the ion transfer in the electrolyte solution result in material removal. And the process of ion transfer is known as electrochemical dissolution. For hybrid machining, there are two examples, hybrid thermal process and hybrid thermal electrochemical and chemical process. For the thermal energy is the main source of the material removal, and the material removal process becomes more intensive with the combination of different phases. That's all from me. Thank you.
Assalamualaikum. My name is Alif and now we're talking about the surface tribology aspect for machining technology. We'll be talking about the theories of friction. So we'll go into the deformation theory, ploughing. When adhesion is small, ploughing becomes dominant. If one surface is harder asperities may penetrate and plough the softer surface. This produces grooves when shear strength is exceeded. This may also occur due to the entrapped wire particles, known as the third body abrader. Interactions between two rough surfaces, known as the mechanical interlocking of the micro or macro infrastructures, causes the ploughing of the surface. Ploughing is when there is an increase in friction and the creation of wear particles. This increases friction at the wear system. As you can see on the left hand side, this is the schematic diagram for three deformation zones in machining. There is the workpiece, which is our current workpiece, flank wear zone, primary shear zone, secondary deformation zone, and the tool used for this ploughing technique. Next will be cutting. An abrasive tip with large attack angle ploughs a groove and removes the material in the form of discontinuous or ribbon-shaped debris particles similar to that produced in a metal cutting operation. This generally results in a significant removal of material, and the displaced material relative to the size of the groove is very little. For example, abrasive wear. Abrasive wear is the most common form of wear in industry. By definition, it is the action of a hard, sharp material cutting through the surface of a softer material. The material is removed by contact with hard particles. Abrasive wear occurs. The particles either may be present at the surface of a second material or may exist as loose particles between two surfaces. Abrasive wear can be measured by as loss of mass by the Tabor abrasion test according to standards of the standards ISO 9352 or ASTM D1044. The abrasive wear mechanism is basically the same as machining, grinding, polishing, or lapping that we use for shaping materials. Abrasive wear occurs in two general situations. So the first one would be based on figure A is two-body abrasion. It occurs when the hard surface is the harder of two rubbing surfaces. For example, grinding, cutting, and machining. And for figure B, it is three-body abrasion. Occurs when hard surface is a third body, generally a small particle of abrasive caught in between two other surfaces and sufficiently harder than that is able to abrade one another or both of the mating surfaces. For example, polishing.
My name is Mohamad Haziq and I will be presenting about lubrication application in machining technology. Lubricant is another name for cutting fluid, which is also sometimes called coolant. There are two main functions of lubricant in machining. The first one is lubrication, lubricating between tools cutting edge and tip to prevent heat and friction. Second one is prevent chips from being welded onto the tool. And the third one A third point, extreme pressure additives sometimes added. So the second function is cooling. Metal cutting generates heat due to friction and deforming, and air has low thermal conductivity. Production works require heavy cutting over a long time, and rather than pausing the tool to cool, we use coolant. So the cutting fluid that is good is able to maintain a stable temperature and maximize the life of cutting tip, ensure safety of the people handling it, and prevent the rust. Tribological system. Before proper lubrication can be selected, tribological system must be identified. The system includes 5 factors. There are 5 considerations before choosing a cutting fluid. First one is type of motion. Is it sliding or rolling? The second one is the speed of the machining. The third one is temperature, because all lubricant has their own optimal temperature. The fourth one is load. Is it light load or heavy loaded? And the fifth one is operating environment. Is it involve moisture or vacuum? And does it has presence of certain chemical? Thank you from us.